We're ready for Lab 7, Activity 1-3. If you haven't yet, please pause this video and read carefully pages 132 and 133. We're going to get into the color codes. That you'll notice that these resistors have little colored bands on them, and sadly I can't get my camera to be a little sharper, but I'll tell you the colors that I see on the bands there. And each of those colors represents a digit that's shown in table 7.1. In OneNote, I put together a code or the same digits, but it's in a table that's a little bit easier to read. So you can look for that in our Lab 7 collaboration space. So we're ready for activity 1-3. We have several color-coded resistors. We'll have 2 digital multimeters. There's one right now. And we've got some batteries. And we're going to measure the resistance 2 ways. And we're going to also compare those 2 measurements to the code that we read. So let's start with this first one right here. This first one at the top. And on page 134, there's a table 7.2. I want you to add a column off to the left where it says R from the code. Off on the left, just put then a column that just says colors, something like that. And then we'll go through this one. So this first one, the colors are, I have to bring it a little bit closer. I believe that's a gray, red, black, gold. So we'll put that down, gray, red, black, gold. And the gray, if we look then at our table, I'm going to back up a page. Gray stands for 8. Red is 2. Black is 1. And gold is our last one. So these colors, read the article that I have in OneNote as well as page 133. Gold will never be your first. If you see a gold, you know it's either the second to last band or the last band. So here we have gold as our 4th band. That's going to be our tolerance of plus or minus 5%. And you can put that in the column where it says tolerance 5%. Well, I guess you can say 5%, but then we're going to want to calculate 5% of what this actual value is. Gray stands for, so we have the 8, then we have the 2, and we're going to have that 8 and the 2, and then we have our multiplier. Black is 0. 10 to the power of 0 is 1, so I have 82 times 1, 82. R from the code is 82 ohms, and then you're going to calculate on your own what 5% of that is. It's going to be around somewhere around 3 ohms, and then it's going to be plus or minus 3 ohms. And then we're going to later, I'll pause the video and I'll grab my multimeter and we'll actually measure it. That's the first one. Second one. Okay, so this one has colors red, black, gold, brown. And I'll do this one with you as well. Red is 2. The second red band is 2. Black is going to be a 1. Now this has 5 bands. So we've got 2, 2, 1. The gold is our multiplier. Gold as a multiplier is 10 to the minus 1 or 1/10. So I have 221. I'm going to take a tenth of that. That's going to give me 22.1. So I have 22.1, and then my last band is brown. That'll mean, give or take, 1%. So take 1% of 22. Wow, 10% of 22 is going to be 2. So 1% is going to be 0.221. So this one has a much smaller tolerance than our first one. Our first one we had a tolerance of around 3 ohms. This one has a tolerance of less of a couple tenths of an ohm. These next few I want you to do on your own. I'll give you the colors, and then you're going to put that from the color column, you're going to decode it and put that into the resistance. Okay, so here we go. Resistor 3 looks to me like blue, red, black, gold, brown. Right, so the first band is blue, then red, black. Our tolerance band, second to last, is, I'm sorry, not tolerance. Our multiplier band, that's going to be an exponent of 10, is gold. And then our last band is brown. That's our tolerance band. That's the third one. Let's take the fourth one. We've got now orange, orange, brown, gold. If I'm reading that correctly. It'll be interesting to put that one on the multimeter and see what we actually get. Sometimes the colors are a little hard to read. Okay, so this fifth one I see as yellow, brown, black, gold. First band is yellow, then second band is brown, third band is black, and the fourth and last band is gold. So this one only has 4 bands. Remember, the second to last band, in this case black, that second to last band is going to be my power of 10, my multiplier. And if you want a little extra practice, here's a sixth one. It looks to be, I'm going to say that's brown, black, 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 brown. So that's actually symmetric. You can read it either direction, it's the same. Brown, black, 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 brown. Okay, so now we're going to individually use the multimeter and step through and measure the resistance of each of these. Well, I've had the multimeter from the previous activity. It's set up measuring current right now. I don't want it to measure current. So I'm going to plug this one into the one that has, that's amps, milliamps. That's the common. This has a V, but it also has that little horseshoe sign. That horseshoe sign is there for omega. And then I'm going to turn my dial to the part of it where I have an omega. That's up here. If I have a sense of how large it is, there's all kinds of, this can measure up to 200 mega ohms. That's 200 million ohms. 20 mega ohms, 200,000. 20K is 20,000. 2K is 2,000. 200 is the smallest setting. So that means the setting that I have it on right now, it'll measure up to 200 ohms. If it's more than 200 ohms, I'll just get this measurement right here. It'll just read a 1. And then I have to say, well, let me try the next bigger one, until I can get a reading that shows me some digits. So I'm going to pause to get set up. All right, I grabbed a multimeter and I tested the first one, and it gave me some weird results. I tried the second multimeter, and it gave me some even weirder results. So I went into my basement, I grabbed my multimeter, and it has the same red color, but it looks a little different. It doesn't have as many functions as the ones from school. And it gave me much better measurement. So I tested it on this 10 ohm resistor. This one gave me a reading of 11 point something ohms. This one gave me a reading of more than 200 ohms. So I think that one's not reliable for it. But this one gave me a reading of 10.0 ohms. So I'm going to go with this one. All right, so when I put our first resistor across this one right here, I get a surprising result. And let me tell you what that is. So here's my resistor. I'm just going to hold it onto it. I'm going to push the probe to one end. I'm going to push it to this end right there. And I'm getting a reading of 50, and it's moving around a little bit in the tens place, but I was getting a reading of about 50.8 was the first one. Let's see if it'll settle down for me. Yeah, 50.7 ohms. So you can write that into the measured R column. Now the code, I had said that it was 81 and we got close to 51. If we look back at our table, it shows that a 5 is green, and when I take another look at it, it still looks gray to me, but maybe it was green at one time, and it looks like it could be a greenish hue. So that's possible, and this is where the color codes can get a little tricky reading them. I'm going to say that this is probably a green, brown, black, and then the gold band. And we'll be able to test that when we move on to the step 3, we're going to test that one again and see what kind of reading you get when we measure the voltage across it and the current through it simultaneously. Let's move on to the second resistor in our series.